shape for the positive and the negative tan for today, because tan requires a bit more information, a bit more detail. Okay. So we are live now. We can make a start. Yep. Today we only have 1 hour this morning, so we want to make the most of it, okay? You guys, when I finish, make your sketch and send it to me. I will correct you. And I'm going to probably give you an assessment on tan graph to do for me. So make sure that you can do it. And then I'm going to get you to, you draw all of them for me on your assessments, to be honest with you. Yeah, then I will see which one is easier for you so that I can put the one that I feel is all right for you in the exams. Okay. So today we're going to be sketching the graph of y is equal to tan x to start off with. Let me just push these ones to the slide. This is our title. We are still on topic 5. Okay, so I've got y is equal to tan x. Yeah. So the key points that you need to know for tan, and you need to write this down, they are very important, okay? Tan repeats itself. The first point is that it repeats itself every 180 degrees. That's every pi, okay? That's pi, yeah? Every pi, 1 pi, okay? I don't even know. What have I written now? Oh my goodness. I can't even get things right. Okay. And the other thing that you need to know is that it crosses the x-axis. Let's write that down. It crosses the x-axis at 0, 180 degrees, at 180 degrees, and then it repeats itself 0 and then 180 degrees, and then it keeps on repeating itself after every 180 degrees. 0 and 180 degrees, and repeats onwards 180 each time. Okay. It has a vertical. No, okay. Let me write the next one first. It has no maximum or minimum value, in which case it goes on to positive and negative infinity forever. It goes on forever, yeah? Upwards, positive infinity and negative infinity. And we'll see that when we will understand this better now when we begin to sketch the graphs, yeah? We'll understand it better when we begin to sketch the graphs. Okay, and also the last one, which I'm going to expatiate a little bit more on, is it has a vertical asymptote, a vertical asymptotes, yeah? That's the word. At x is equal to 90 degrees, x is equal to negative 90 degrees, x is equal to 270 degrees, and so on, yeah? 160, 180, 180, 180, keeps on adding on. The first one starts at 90 degrees, and the next one will be on 90 degrees. And I'm going to tell you what an asymptote is now, okay? So if you finish writing down everything that I've put on the board, then I can tell you what an asymptote is. An asymptote a straight line that continually approaches a given curve but does not meet it at any finite distance. So an asymptote is a straight line. You will understand now. Just make a note of everything I've written. You will understand it now when we start to make the sketch, okay? I will explain a bit more when we start to make the sketch. Okay. An asymptote is a straight line that continually approaches a given curve, but does not meet that curve at any finite distance. It's approaching the curve, it keeps on approaching the curve and tries to meet the curve, but never meets the curve at any distance, okay? So now that we know all the knowables, let's make a start on sketching the graph. I'm going to start to draw my x-axis. My x-axis here, right here. Okay, and I'm going to draw my y-axis. That's my y-axis up there. And we want to draw this graph. We want to draw it for what's the limits now? Let's choose some limits now. Let me see. Y is equal to tan x for 0. Let's do it for 0 to 2 pi, okay, which is what we've been doing. Y is equal to negative tan x for 0 is less than or equal to x is less than or equal to 2 pi, okay? Or you can put 360 degrees. You need to get familiar with the two of them, with them. That's why I keep on using it. Okay, this is x. Make sure that you have your pen and you're following, or your pencil and you're sketching along with me. Yeah, make sure you have your pencil and you're sketching along with me. Draw the x and the y axis. Yeah, we said it repeats at every 180 degrees. It crosses the x axis at 0. So this is my 0 here. It's going to cross there. And it repeats at 180 degrees. So it's going to repeat here. Again, it's going to cross it here again. Okay, and it's going to cross it at 360 degrees. But there is an asymptote, okay? And at 90 degrees, there is an asymptote. Let me change the color of that pen. You need to use broken lines to indicate your asymptotes. So there will be an asymptote at 90 degrees and another asymptote at 270 degrees. Yeah. So let me put my degrees in, or radians. This is 90 degrees and this is 180 degrees, and this is 270 degrees, and this is 360 degrees. Yes, draw it in paper, Hamad. You don't need, because we are just sketching, okay? We're not drawing the graph with, I'm not giving you the XY table and asking you to draw it. We're just using the information that we know about tan to draw the graph. So we are only sketching, yeah?
Thank you.
So now what you need to do, you need to put in your asymptotes, yeah? You need to put in your asymptotes. So, and we always use broken lines to draw asymptotes. So I'm gonna put, when you do this in your book, use broken line for me, okay? Because you're supposed to use broken lines. And put an asymptote on 90 degrees. Because I'm using my computer, I cannot use, I don't have the function for broken lines. And put another asymptote at 270 degrees for me, okay? I think we should extend this. We should extend it for -3 seconds. No. Let's extend it to -90. Yeah, because so that we can see it properly. So put 9 here, -90 degrees, or negative pi over 2 to 2 pi, okay? -90 to 360 degrees. Okay, so there will be an asymptote on -90 as well, if we're going to include -90. I'm just going to use my blue markers for my asymptotes. Yeah. Okay, so you got your x-axis, you've marked all the asymptotes, you marked them, you've drawn them, okay? You know where they are, you drawn them, you marked them, okay? You know where it's cutting, where the graph is cutting the x-axis, and you've marked them 0, 180, and 360, yeah? So now you're going to draw your graph, okay? You're going to draw your graph. What color pen? I wish they had gray pen. That would have looked more like it would have looked more like a pencil. I only have basic colors here to play with. What color should I use? Okay, I'm gonna use this. No, so faint. I'm going to go with red. Okay, so this is my turn now. Yeah, I know it's cutting 0, so I'm going to, and it's going to be approaching this, or this line is approaching it. It's going all the way up, yeah? And then, sorry, it's so hard to draw with this digital pen. And then on the negative side, it's like it's coming down and trying to touch that line, but the line is not going to touch it. Yeah, so positive infinity and negative infinity. That's the first one. Yeah. And the next one is going to cross at x at 180 degrees, and it's going approaching the asymptotes. So positive infinity and approaching this asymptote to negative infinity. I can't even talk anymore. Right. So at 360, we should have another one going up, but our graph ends at 360. So this is where we're going to end it, down here. Okay. So that's where we're going to end it. You will not have, because if you draw the next one, you have gone beyond your limits. If you draw up, you can draw it, but it did not ask you to draw it. So you can draw it. There's going to be another asymptote here after 360. Yeah. So that's your tan graph. That is your tan graph. So you have your pi over 2. Let me use green pen. Pi over 2. 2 pi over 2. 3 pi over 2. 4 pi over 2 in radians, okay? And you have negative, oh, this is 0, and negative pi over 2 here. All right, so that is it. That's your time graph done. You need to sketch this now and send it to me fast so that we can have a look at it. What time are we ending? 11:50. Yeah. We can have a look at it and we can correct you and see that you're doing it right, okay? You need to make a sketch of this now quickly and send it to me. Let me see, I hope I've shown you everything. This is going down here. I'm just going to use the black pen to draw my asymptotes so that you see them more clearly. One. Oh, undo. You're supposed to, you need to use broken lines, okay? You need to use broken lines to show that it's a line that this is trying to approach the graph, but never really gets to it, yeah? I think that's looking better now. I feel more at peace with myself. Okay, so yes. So this is what it should look like. It's approaching, it repeats every 180 degrees. Yes, it does. This is the graph. 0 to 180 degrees, 180 degrees to 360. Yes, it does. It crosses the x-axis at 0 and 180 degrees and repeats onwards. So it crosses at 0, it crosses at 180, another 180, and so on. It has no maximum or minimum values, and you indicate that using the arrows pointing upward and downwards to show that it's going upward infinity and downward infinity, yeah? It has vertical asymptotes at x is equal to 90, x is equal to negative 90, x is equal to 270, and so on, yeah? And you've indicated all those key points in your graph. Then you can send it to me. I need to put my computer on so that I can know when you send it to me, let me know, okay? Because I have to go onto the other computer to check it for you.
I've sent mine, teacher.
Have you?
I have sent mine.
That's so fast. You people, did you even draw? Did you? Were you drawing it when I was drawing it at the same time? Okay, so let's have a look. Oh, Khaled and Hamad have sent already. Okay, Khaled's one came in first, 10:45. So let's see Khaled's one first. I'm going to join the. I'm going to join it. Okay. Where's my mail? Let me join the stream so that I can share with you guys, okay? Let me join the. I don't even know what I'm joining. I can't find my words. Okay. Sorry. Leave computer audio. Yes, it's not going to be that loud anymore. Okay, so let me share your thing with you. Oh, I haven't made myself the host. Participants. More. Make host. Yes. Okay. My glasses. Let's share yours. Palette. Share screen. Yes. Share. Share. Okay. So Palette, this is yours. Well done to you. The only thing that I will correct on yours is that I'm going to use annotation now. I'm going to use broken lines here. Okay, I'm going to use broken lines for your. Just put your ruler where it is, and instead of drawing a straight line, you draw it broken. Okay, do you see how I'm doing it?
Yes, yes.
Yeah, that's all. That's the only thing that will give you the full marks now. You're fine. Everything else looks fine to me. Okay? Well done. Okay. Hamad, let me open yours now. Let's have a look. Share screen. Share. So this is yours, Hamad. Yours is looking nice. You put your asymptotes in at the end when I put mine in. Zero, 90, 180, 270, 360. Well done to you. Okay. So yours looks fine. Yeah. So if you have to do that for me in the exams, you remember how to put everything in. You remember the points. Make sure you have a copy of this and you can follow it. Okay. I may ask you guys to transform it. So that's another thing you need to know how to do. But once you know the key points, then you can do it. Okay. Did anybody else send me? Let me check. Nobody else. So I'm going to go back to my.
Miss, can you go back to the sketch?
To the sketch, eh?
Yes.
Okay. I have to make myself the host. Make host. Yeah. So Share screen. Whiteboard. Share. Okay. Okay, who are the rest of the students in this class that I'm not hearing anything from? When it's after the exam now, you will be looking for me and telling me that I'm not fair to you. But I have given you work to do now, and I haven't seen anything from you. Apart from I know Rim, you're working on it. But Khaled Bauji, where are you? Abdullah Aloud, I haven't seen any work from you. Abdurrahman Alanzi, I haven't seen any work from you. I need to see work from all three of you that I just mentioned your name. Uh-huh. Okay, let me check first of all. Abdurrahman, now I've seen yours. Now I'm happy. Yes. I want to see your work in class. I want to see that you're participating. That's what I want to see. Very good. So that if I give you 50% or 100%, I will know that I gave you that mark, and that mark is what you deserve. Because I've seen your work. I know that you can do it. Okay. Okay. Right. So let me share. Abdurrahman, I'll share yours first, then I'll share Rim's one, okay? Share screen. Yes. Okay, well done to you. Let's have a look. 0 to 90. I like that you use your broken lines. That's good. 90 to 180 is cutting. Yeah, well done. I can see your degrees and your radians. It didn't come after oh yeah, you did. So this is negative pi over 2, and this is negative 90. Yeah? So make sure you put your negative 90 there as well. Yeah? If you're putting it has to be in degrees, put the 2, because we want to make sure that you can do the 2 of them. You know what to put where, everything that needs to go where it needs to go. Okay? Negative 90. 0, 90, 180, 270, and 360. You're pointing your arrows down and arrows up to show it's going up to infinity. Well done to you. Stop share. And I'm going to share, Rim, I'm going to share yours now. Oh, you sent yours like, I have to download this now because I have to turn it upside down. Because it's coming upside down. Yours is looking very neat. Typical girl. Always tidy, not like the boys. They're not going to be happy with me now. Oh my gosh. Right. Well done. Yeah, perfect. I love it. It's neat and tidy. And I can see you took your time to do everything. Although here it's touching, shouldn't be touching. Yeah, it's going to negative infinity. It's going to close to the asymptote. Take it a little bit away from the asymptote so that it looks like it's trying to touch, but it's not touching. Yeah, that's the whole idea. Okay, so that's the only, your presentation is very good. You put your x and your y-axis and your graph, your tan graph is going up to negative and positive infinity, and you put your answers in radians and degrees. You put the markers on your graph in radians and in degrees. So I'm happy with that. I'm well pleased with that. Okay, well done to you all. Okay. The only person that I didn't hear from is Abdullah Aloud, which I'm worried about, and Khaled Bauji. Okay. Right. Stood right there. I'll stay here. So the only other thing that we're going to do is to show the graph of y is equal to negative tan x, and it's the same thing as that one. It's just that it's going in the opposite direction. Okay, so instead of going this way, it's starting off. It will be something like this. Hang on a minute, let me choose. So it will be something like this. Okay, y is equal to negative tan x, okay? And so that will be this one and this one. And here, it will be going from here and down here, okay? And here, it's cutting at 360. Yeah, so this time, it will be up here, not in the bottom, it will be up here. Maybe going to the other side, but can you see the transformation? Yeah, so that is y is equal to negative tan x. All the other things are very complex. We're not going to go into them. We're not going to try to go into drawing y is equal to this and that. No. So that is what we're going to do. Okay. Now the next thing that we're going to have a look at doing, which I probably start with it today, but I'm not sure we'll be able to meet up doing all of it. But at least let's have an idea how to work it out. Is how to solve trigonometric equations using sketch graphs. Okay, now that you can sketch the graph, you need to know how to solve trigonometric equations using sketch graphs. So let me get my book out. Okay, so solving trigonometric equations using sketch graphs. So I think that's towards the end of topic 5. I thought we would do this tomorrow, but we finished our time graphs quite early. So maybe we can do it today. We can make a start on it today, and tomorrow we can expatiate on it. Can I clear everything that is on my board now? Yes, clear all drawings. Solving trigonometric equations. That's the next title that you need to put. We're still in topic 5, okay? Using sketch graphs. Okay. Now you have learned so much with me. Okay. Right. So let's say you have, let me look for my example. Maybe tomorrow we'll have some to do on my maths. I'll give you some on my maths, but today let's just play with it and see what it looks like. So let's say you have the equation sine x is or y is equal to sine x, or sine x is equal to 0.5, yeah? Maybe you're being asked to solve the equation sine x is equal to 0.5. Solve. Sine x is equal to 0.5, yeah? For maybe for 0 is less than or equal to x is less than or equal to 360 degrees, yeah? So the first thing that you want to do for this is to sketch the sine graph, okay? To sketch the sine graph, you're going to draw your y-axis and your x-axis. You know that it completes a full cycle at 360 degrees. You know where the markers are in the middle. It has 180 there, you have 360 here, you have 90, and you have 270. You can write them down if you want to. Oh, 270 there. Yeah, you know, it starts, okay, and this is maybe, if this is 1 and this is -1, then this must be 0.5. This is 1, and this may be -0.5 and -1. Okay, so your sine graph starts from 0. This is 0, yeah. It's going to have a turning point there, another turning point here, yeah, and then it will finish off at 360. It will start from 0. No, there's a turning point at 90, yeah, and 270, and it cuts at 180. Yeah, now I'm right. Okay, so you'll have a turning point here. It's going to turn back, cut at 180, and turning point there, and finish at 360. Yeah. So now you've sketched your graph. You got X, you got Y. You know what the graph looks like. Sine graph looks like that. You know it. Cosine looks like this, like a bucket. And tan looks like this. Oh gosh, what did I just draw? Tan looks like this. This, okay. Okay, so you sketched it. Once you sketched it, then go to your calculator. If you know that sine x is equal to 0.5, then what is x going to be equal to on your calculator? Use your calculator to find the sine inverse of 0.5. Pardon?
30.
Yes. So it's 30. Yeah. So you have one solution. So what you need to do now, once you got your sine inverse to be 30 degrees, yeah. Now you can draw a line from here. Okay. You know that there are going to be two solutions there. There's one solution at x is equal to 30 degrees, yeah, where that line is touching the x-axis. This line is coming down, sorry. There's one solution there where this line is coming down and touching the x-axis here. There's one solution there, yeah. Now, what is this other solution? How do you work out this? So there's two solutions. How do you work out this other solution? I want to use a different color pen. So your first solution is going to be here. You got one solution there, and you got another solution here. At 30. So from your sketch graph, that is 30. From your calculator, this is 30. Don't worry about what you sketched, yeah? Now, you know that there's another solution here. If this is 30, yeah? If that's 30, then this other solution here must be equal to 180 minus 30, yeah? 180 minus 30 will give you this solution here, this solution, the next solution. Don't worry about what your graph looks like because you only sketched it, but now you're using your sketch graph to pick up the two, how many solutions you have. You got two solutions. One of them is at 30. The other one must be at 180 minus 30, which is what? 150 degrees, yeah? So those are your two solutions. All right. Those are your two solutions.
Teacher,
Yes?
why you go from 0 to 1?
Why do I go from 0 to 1?
Yes.
Where?
From 0 here in the drawing.
Here in the drawing?
Yeah, no, on the right.
Here?
No, I mean, I don't know how to explain.
You don't know how to explain it, so now it's a problem. Write your question in the chat for me, please. Writing is easier sometimes. Okay. Now, you are going to you are going to find using a sketch graph. It's just the sine graph. I cannot stop at 0.5, okay, because it is sine x, okay? It is 1 sine x, okay?
Oh, okay.
You understand? It's
Yeah.
1 sine x. It's not 2 sine x or 0.5 sine x. Okay, so this is how you do it. If it says to find the other solutions for using a sketch graph and your calculator, solve the equation sine x is equal to this. You're going to get one solution, only one solution from your calculator, but you have to work out the other solutions. How to draw it, Hamad? That's what we did all of last week. Oh, this girl, leave me to work now. Right. So you guys draw use a sketch and a calculator. Yeah, this is your problem. Let me type it out for you. Ooh. Solve the equation. Cos x is equal to 0.309 for values of x between 0 degrees and 360 degrees. Okay, I hope you remember how to draw cos x. And that's your question. I hope you know remember how to draw cos x. I'm not going to show you. You start from the one and you remember how we did it, yeah? I'm not going to show you. Have a look in your notes. It's your challenge, okay? It's your question. If you've been paying attention in class, you should be able to do it. Hmm. Hmm. Anybody finished? Is this too challenging for you guys? Come on, you should be able to do this. Huh? Have a look at how you sketched the cosine graph last time and put your 0.309 on this line here. Yeah. And then find the 2 points where they meet and then get your answers. One thing that I need to tell you that will help you to understand this a little bit better is that this graph is symmetrical. It's symmetrical, so whatever is happening on this side is happening on the other side as well. from that point where it cuts the x-axis, that from that point of from the maximum point, it is symmetrical on both sides. Yeah, so if you have 30 on this side, this solution is 30 here, then this solution must be something, this distance here must be 30. That's why here is 150. Okay, so have that at the back of your mind. Okay, guys, come on. You can do this. You can do this. Come on. Summer is here with no summer. Okay, I think I got somebody's one. I can hear the sound. Let me see. Let's see who is the first one to get it down. Let's have a look. Oh, Lynn, welcome to you. I have to download yours because it's upside down. And the first thing that I want to tell you by looking at it firsthand is that you draw a sine graph instead of a cosine graph. So you need to draw a cosine graph. But I'm going to still share it with you and tell you what your graph should look like. Okay? Right. So, and that's why it's good to do. Let me make myself the host so that I can share it with you. That's why it's good to do the work so that you can be corrected. If you don't do the work, you won't know what mistake you're making, and in the exam, you will be messed up. Yeah. Right then. So I'm just going to share the screen now. Yeah. Share. So this is yours. I like the x-axis and the y-axis that you've drawn. But you need to remember that your cosine graph, let me annotate for you. Your cosine graph starts from the top, cuts through 90 degrees, minimum point at 180, back up, cuts through 270, and finishes at 360. And then you have to draw that line from 0.307 and find your two solutions. Yeah, you need to draw that line and find your two solutions from your graph. Okay, from your calculator, what is cos inverse of 0.307?
It's 72.
72, yeah, 72. So that means your solution should be down here, less than, it should be less than whatever it is. Yeah, it should be less than 90. Yeah, 72, which means from here, let's see, it should be you should subtract 72 from 360 to get your answer. Okay, do you understand?
No.
You don't? So I just said just now that these graphs are symmetrical. Yeah, so what you have on this side, what you have on this side is the same thing as what you have on the other side. Yeah, if this place here, if this point here is 72, this distance, it means that this distance here is going to be 72 as well. So how do I know what is here? I only know what is here by subtracting 72 from 360. Yeah?
Yes.
So that's how you do it. That's how you do it, because you know the first one is 72 is here, and you know that this side is the same thing on the other side. So the other side is going to be 72 here. So to know what is at this point, you just subtract that 72 from 360 and you get that solution there. What's the answer?
Teacher, how you get 72?
From your calculator.
Cosine what?
Cosine inverse.
Oh, okay.
Yeah?
Yes.
Okay, so you guys, so Rim, you need to work on that one again and send it to me so that I can see your two solutions. Yeah, and the rest of you need to do the same thing. Well done to you, Rim, for being the brave one to send yours first, because it's always brave to send yours first, because lots of people don't want to be told that they are doing it wrong. So you are the brave one. I'm going to go back to my whiteboard. So let me make myself the host more. Host. Yes. Screen. So now that I've explained what it is to you guys, I can just make a little sketch on the board here. For this one that I drew before, yeah, there's, yeah, because the sine graph is all happening on the top in the positive direction from 0 to 180, and it's all happening in the negative direction from 180 to 370. You only have those two solutions between 0 and 180 degrees. But for cosine, it's much longer. It takes more of the space. So you have it going all the way. You have one solution close to 0 and another solution close to 360. Yeah. So I need you guys, if you were paying attention, to sketch your graphs and send it to me. I ring you to correct yours and send it to me. Okay? So that you know what to do in the exams. I'm not going to ask you to draw this cosine of, I'm going to tell you to draw, so sketch it and find the solution of so and so thing, so that you know. So that you know. Oh, this is the worst graph ever that I drew. Mm-hmm. And you find your first solution, which is going to be somewhere here. And then you find your second solution, which is going to be somewhere here. Okay. Yep. Let's see who sent the work in now. Yeah, Hamad. So that was you. That's your graffiti that you are drawing. Okay, let me participants. Make host. Yes. Okay, I'm going to share yours now, Hamad. Okay, we'll see how you did. Well done to you. At least you are enjoying this one. At least you are enjoying this one. You're not crying. Okay, so I like all your graffiti. Well done to you. Look at how many lines. Look at what you're drawing. So maybe that's when I'm talking. That's when you're drawing all that drawing that you're doing. Okay. Yes, your graph is looking nice, and you got your solution and your second solution, and you showed your cos inverse to be 72. Well done. So your second solution. Well done. So that's how we do it. Yeah. That's how we do it. And you have to know which graph they're asking you to draw, okay? If they're asking you to draw the sine or the cosine, or which one are they asking you to draw, you sketch it and then find the solution. I'm not going to give you to find solution for tan, okay? It's either going to be cosine or sine, all right? Let me see, I think so. Yeah. So Reem, you sent yours. Let's have a look at yours. Well done. Share screen. Well done. Okay, so that's looking much better now. Yeah. Let's do full screen. Yeah, so the only thing I'll put here is my line there. Yeah, I'll draw that line to make sure that I'm representing it properly. So just put that line there on yours now, correct it in your sheets. Yeah? Is this, oh, Hamad, is your answer correct? Check your answer. I think it's 288. Is that what you wrote? It's meant to be 360 minus 72. Yeah? So check your answer for me, all right?
So 118 minus 72.
No. See, your graph this time, can you have a look on the board here? The other time it was 180, but now look here, it's 360. Yeah, look where the symmetry is. I'll show you now. And I'm not trying to confuse you here, but this is where the symmetry is. So everything on this side is equal to everything on the other side. So if here is 72, then the end of your graph here must be 72. Yeah, this distance here. So this time, instead of doing 180 minus, we're doing 360 minus 72. Yeah, that's the difference.
Here
So
that
make sure,
is,
make sure you remember that. So correct it now on your graph and remember it, okay?
thank you.
All right. Okay, whose one is coming in? So Reem, well done to you. So well done.
Thank
are
you.
the
Miss,
pacemaker.
this is topic 5.
It's topic 5. It's the end of topic 5.
Okay.
Yeah, because we sketched all the graphs and now we're using the graphs that we sketched to find solutions to trigonometric equations. This is the end of it. Tomorrow, hopefully, we start a new topic if exit full screen. Let me see, someone sent me. Oh, Khaled. All right, let's have a look at yours. Well done. Okay. I'm going to share yours now. Share screen. Khaled. Share. So yours is looking nice. Yeah. Got X, Y, 0.309. You got your 72 by putting it in your calc. You need to put here, you need to write, if you're doing it for me in the exams, make sure you show all your workings out, okay? So write how you got sine X or cos X is equal to 0.309. X is equal to cos inverse 0.309. Then you put your answers in. You put your answer in and then you show it the first solution and your second solution, yeah? So the first solution is where the graph cuts where the graph, where that line touches the graph, and you have to follow that down to the x-axis, which you've done very well. So well done to you. Yeah? So just show your workings a bit more. I know boys are lazy to write. But show your workings a little bit more. So apart from that, it all looks fine. Yeah. So guys, I think we've come to the end of topic 5, yeah? Well done to you all. I think I should put some work in now for topic. I don't think I put anything in for topic 4, but there's quite a few things on there that you were supposed to do for independent learning. So if you haven't done them, too bad, because they might be coming in for your topic 4 assessment as well. So I'm going to put something in now for topic 4 and 5 for you guys to complete for me, okay? And I'll try and see if I can stay on top of marking everything now going forward, okay? There's been so much going on. Yeah. Any questions?
No, teacher, thank you.
No. So I'm going to be in the background. If anybody has any questions to ask, you can stay back and ask. If you did the receipt exams, you will hear from Andre very soon, okay? Because I've collated the results and I sent to Andre, and nobody failed, all right? Everybody passed. So, yeah.
Okay, thank you. Have a good day.
And you. Bye now.